Okay, I'm gonna start talking. So first one was an attempt at a pun, but also it's the thing we've been working on in the last couple of days. So we've been working on the garbage collection stuff, and we picked up the first story was about deleting container images, and in particular the package container images, so the one with source code, when a package is deleted. And we really thought that we could get away with just using the registry spec APIs for deleting images, but it turns out there is a lot of differences and inconsistencies in the different implementations. So we've noticed, for example, that some registries will delete an image if it's untagged. They consider it dangling and they'll kill it. And some won't, like Google will not. And then we noticed that some registries don't allow you to delete stuff, period. They just disable that API. You get an error saying deletes are disabled. Some will refuse to delete an image if there is a tag pointing to it. So you have to delete the tag first, if you have permission. So at the moment, I think we have a piece of code that tries to delete the tag, and then if it succeeds, it tries to delete the image. Actually, if it fails, carries on, tries to delete the image. If it fails, carries on. So it's very resilient, and it achieves different levels of, I guess, success depending on which thing you run it on. We were just thinking, like, are we happy with this? Because I guess more stuff could be achieved if we explored maybe proprietary APIs. So I don't know, maybe Docker has its own way of deleting images that is not the one in the spec. And the other thing that came up was actually, like at the moment for packages, for example, we're not tagging every single package we push. So it means on some repositories, we're actually losing old packages, while we should be retaining up to 5, I think is the default. But it might be that at the moment we're not doing it just because we're not tagging them explicitly, and some registries might be deleting them without us really knowing. It's true that we don't implement the rollback APIs, so it's actually hard to go back and build an old package with the CLI, but I think we still want to retain them in case people want to do this via the API, or I don't know, they want to maintain the 5 different versions of the source code in the registry. So one fix we might have to apply is we want to tag each single package we push. And then, but that's easy. The main question we're trying to answer now is, how do we implement this deletion procedure, like a deletion procedure that we are happy with, that we consider acceptable across the registries, given they're all so different. I think we've tried Amazon, Docker Hub, GAR, the Google Artifact Registry.
Yeah,
and then we've tried
Docker Hub is the one so far that doesn't actually work. So you can't do a delete on Docker Hub via the V2 API. You have to go through Docker Hub's own API to do that.
Is there an option to delete the whole repository when the app's deleted?
That isn't in the API either, so you'd have to go custom for that anyway.
Yeah, that's definitely not part of the spec. And it's weird because like you get it created for free when you push, but then you cannot take it. You cannot remove it. Like if you delete all images, it doesn't go away. So that's also funny because doesn't mean we have to delete it. Because we didn't create it. So technically, should we be the ones who delete it? But that's a different story, the one for deleting repositories.
Also, I mean, I don't know. What was I going to say? You really want your repositories, your registries to be quite close so you don't get any network latencies and things like that. But I suppose people would tend towards using like ECR if you're on AWS or one of the Google ones if you're on Google Cloud. I mean, but there is the option of suggesting people install a local registry and then sort of give premium support to that and make sure that works solidly. Something like Harbor, I don't know if that's open source or
not. There is an open source version of Harbor, isn't there?
Yeah, it's like a CNCF thing. So it's like, I don't know, pretty legit open source.
I don't quite understand the relationship between all these things, but like there is a distribution/distribution repository, which technically contains a reference implementation of sort of the distribution spec. And we've been using it for tests because it can be run in memory. But that's a fourth behavior. That behaves differently still. So that's another option, like if you want an open source thing to run. Because then there is the thing that we install on Kind, for example. That's an even different thing. Like that's Docker, but it's not the one in distribution/distribution is a different one. It might behave.
It's a Docker/distribution instead. Right.
But these two things behave differently than Docker Hub. Maybe they behave the same between them, but I'm not entirely sure. It's a mess. Like the spec is very vague and pretty much everyone has implemented the bits that are not explicitly specified in the spec in a different way.
Like on Google Artifact Registry, you can't delete a manifest if it has any tags pointing to it. And on ECR, if you delete a tag, then the manifest, the image gets deleted if nothing else is pointing to it. So
cool. Yeah.
Very weird stuff going on.
Yeah, I left a comment on your PR the other day just because I remembered we tried to solve this in like 2020 in CF for Kates and eventually like kind of gave up. Not intentionally, but I had optimistically hoped that this whole landscape had improved because it looked like you had a PR and stuff, but it sounds like it's just as bad.
We could do like reasonable effort there. So like,
yeah,
it's Docker Hub that's causing a problem at the moment, but we could log that things aren't being cleaned up. We haven't tried Azure and GCR. Presumably GCR will be a bit like GAR.
Would would what Julian just suggested make this simpler though, where you only delete it if the app is deleted? Because then you don't have to worry about trying to delete by digest or like hoping that there's a tag and everything.
You'd have to delete the whole repository, but there's no generic API for that, so we'd have to go.
Sure. So you'd have to go ultra special case. The reason I'm wondering is just because since we're pushing everything to the same images, like I think the amount, assuming stuff is reused between these pushes, like the amount of cleanup you get from an individual package being deleted isn't that great.
Yeah, and we already have that sort of specialization for creating repositories because we need that for ECR. So we'll definitely have a custom deletion repository for ECR. So the pattern exists, but we'll have to explicitly just support a set of registries, and you just have to hope that, well, I mean, if you introduced a new registry, then it wouldn't work with Karifi out of the box, really, or the deletion wouldn't work anyway.
Perhaps, but the set, like if you consider like Harbor as like almost a reference implementation of the spec, and then support like the major clouds, maybe that's
there is no common spec for repository creation and deletion. It's only the registries just give you a custom endpoint for it. There's this thing called the V2 API, but that allows you to create images, create tags, delete them, upload stuff, list the blob if you know its ID or something, and it's literally about that. The repositories don't enter into it at all.
Yeah, that's fair. I guess we never did try to do the repository. I'm just remembering back to CF for Kates, Harbor and GCR behaved the same almost at the time, with one caveat where one let you delete by digest and the other didn't. But but I don't know. Like I definitely remember Docker Hub being the worst of them all, and I feel like it is not something people would actually use.
Would use.
Yeah, it's more of like a kicking the tires type of registry for something like Karifi.
Yeah, what concerns me with going with the proprietary approaches is that then authentication becomes funny. Like now we already have credentials to push, and we want to use them for deleting and stuff. But now we'll have credentials for pushing, which are the regular credentials like passed via basic auth using the Kpack protocol. And then for delete, for managing repositories, you need its own authentication. Like for ECR, we got away with it because the whole point of it was it's all via service accounts and it recognizes that it's an Amazon node and it does everything magically. But like if it's, I don't know, something else, you need to authenticate. How do you even do that? Like that doesn't sound easy. Like you have, if you want to use GCR, for example, you have to allow us to, I don't know, mess with your GCR repositories. Like, how do you do that? Maybe service accounts or stuff, but like that will need to be configured in Karifi. Yeah, maybe we need some more exploring on this. We really thought that the distribution API would just suffice, but it clearly doesn't.
So nobody's written a library that solves this for us.
Now there is the Go container registry library is pretty good, but to the same calls, registries react differently. Like, and the Go container registry doesn't have all those differences between implementations in it. It doesn't. It just does what the API, the spec says. So the spec has a delete endpoint, but then you run it against Docker Hub and you get an error saying deletes are not allowed. Is that part of the spec or not? Arguably, but it doesn't work. And that, or sometimes you try to delete a tag, again, you get an error saying, oh, the tag is already, no, sorry, you try to delete an image and it says, oh, there's a tag pointing to it. Spec doesn't say anything about preventing images from being deleted if a tag is pointing to them. Like they just decided they would do it this way. So the library implements the spec endpoints, but it doesn't handle.
It doesn't have any of the proprietary stuff. Yeah, it's disappointing.
So yeah, I guess we'll keep trying and yeah, we might settle with this kind of best effort approach where like, okay, if your registry doesn't allow us to clean up after ourselves, we won't. We should probably document these things.
Yeah, like I think even just documenting how these things are named and that someone could clean them up themselves would be good too.
And for registries, it's tricky because for registry, we don't have any other way, unless again, we say we don't do it. So yeah, it's going to be a tricky one.
Probably not that critical if it's empty, right? The blobs are more critical because they take up space. So
yeah, that's fair enough. That's fair enough. It's annoying. We leave like this massive list of empty things behind. But yeah, in terms of like space, yeah, it would be cheap. Okay. Let's carry on. We've been talking about this for a while. Kieran, you want to talk about Kpack stuff?
Kpack, yeah. As a little summary then, for those of you who haven't seen this. Somebody in SAP spotted that if you turned on one of the cache arguments in the Kpack image, then subsequent builds were really, really quick. And it seems like, so in Kpack you have an image, and then every time you modify that, a build is created, or every time it detects that something from the cluster builder has updated, like the stack or the store, which is the build pack list, and that affects anything you've built, then it'll create a new build again. Yeah, and by default it uses a PVC to cache stuff. Yeah, and it tends to work pretty well like that. So if we had the approach that every time we pushed a new version of the app, it would just update the source reference in the Kpack image, then it could take advantage of all the caching for that build. It would just be like doing stuff locally. It would have all like your Go modules in the right place, and all your intermediate builds cached as well. So like I did a test with Karifi. If you modified Karifi and pushed it twice with Karifi, first time took about 1.5 minutes or something, and then it went down to 5 seconds the second time. So you're getting that sort of improvement in the build time, which I think is really important. At the moment, though, we associate a Kpack image with a build workload, which has like a one-to-one with a package, and you get a new package every time you push some source to an app. So we don't get any like source level caching going on. There's something that the build packs can do, and they try and download the previous image from the previous built image from the repository. But if it's something like Go, there's nothing in there that can help you with caches anyway. It's just a binary. Possibly with other languages, I don't know. There might be some artifacts in there that could be reused more easily. Yeah, so yeah, there's that document link there, Kpack caching enhancements, and we were wondering if it makes sense to go and change that relationship so that you have a one-to-one between a CF app and a Kpack image. And then every time you create a new build workload, it would just be associated with one of the builds that gets triggered from the Kpack image. And we did a prototype in there that's linked from the document. So it does make things go a bit faster. But then we had some comments on that in Slack as well. So what's it? So this is all about Kpack dealing with build pack changes and stack changes. So if you change a stack, the cluster and the cluster builder is updated, Kpack allows you to do this rebase or operation, which just goes and swaps the stack layer in the image, which is pretty fast. And if you update a build pack, then it just rebuilds the whole thing for you, which is ordinary sort of speed. We noticed, so that's happening in Karifi at the moment, but we're not taking advantage of that because we just get a new build on the image. But the build workload reconciler, no, sorry, what am I thinking of? The new build doesn't end up on the droplet basically because the reconciler says, no, I've already built it, I'm not going to look anymore. So we don't get any updates. But yeah, one of the arguments was, yeah, so if something like that happens, then all the builds in the system will be updated. If we change that relationship, so we've just got one image per app, only the latest build will be updated in that way. But it means that, yeah, anyway, those are the arguments I say. Oh yeah, and the last thing I wanted to say was, so there's two ways that Kpack can cache. It can use the PVCs, or you can ask it to use a container image if you pass it a registry, a repository path. But with a quick look at that, it got really big really quickly with the Golang. And then over the network, it's going to start taking longer to download the cache from the registry than it will save you when you're building your thing. So that was kind of an option that you would be able to set a registry tag that like is based on the app name, so it's shared between all the different builds of the app. But I just don't think it's particularly good for that reason unless you can use a local registry.
So do we know like what size the PVC needs to be? Or I mean, is there a way to control that? in
Yeah.
a way that won't just cause it to run out of disk instead of like flushing.
Yeah, it's in the image spec, defaults to 2 gig, and you can specify
Uh-huh.
whatever you like. I think Kpack have an ongoing bug for it though, saying this thing will grow over time, and they want a way to prune it. And then the Kpack people have said, more complicated than you think, because it might be mounted all over the place. But at least they're looking at that.
Okay. Well, that would be useful to know. I mean, like if it's going to grow unbounded and eventually fall over, then that's the kind of an argument for using the container image.
But yeah, the container image doesn't have any bounds on it, so that'll just get worse and worse forever.
Sure. Yeah. I guess the other question I had was like, are we able to do all of this without breaking the abstraction that we have that we've introduced with build image?
Which one's that?
So in other words, we're kind of separating out the Kpack logic from the Garifi logic with this build image abstraction.
Build workload.
Sorry, build workload.
Yeah,
I'm terrible at remembering the right term. And now we're saying, well, it used to be that build workload spawned an image, and now we're saying, it kind of doesn't, unless there isn't one. All right, is all of this logic? Are all the logical changes constrained to the Kpack image builder?
Yep.
Okay.
Yep.
So we're not changing that contract in any way. We're just sort of saying like, to the app that's referenced in the build workload.
So the build workload it's a bit dodgy. It has a label on it called app GUID.
Sure.
And we'd use that to name the image. No. Yeah, we'd use that to name the image.
Yeah.
No, what am I talking? Oh.
Yeah, that doesn't seem that dodgy to me. I'm pretty sure we rely on that already.
The reason, the way we managed to have this, like, to keep this, to have one CR, so one build workload per build, despite having one image shared between them, is that we use the image for writing. But like then for reading the status, Kpack has a lower level object called KPAC Build, which is one per build. So like for knowing the status and getting the droplet, we get it from the Kpack build. Or like when we want to trigger a build, we don't create it manually because it's a bit lower level than we like. We modify the image instead, and that triggers a build. So you end up with one image per app and one build per build. And it does mean we need to read these Kpack builds, which are a bit lower level objects, but they are there and they have all the information that we need. It kind of works, yeah.
Yeah, I think we intended on reading those to begin with. We just never got to it, just because like this stack rebasing stuff that's covered later, that's how that worked in CF for Kates, and is like a necessary way to implement that.
Does the Kpack image have a link to the last build it spawned, or do you have, okay. So it's pretty easy to discover at that point.
Yeah, I'm pretty sure it's in the status, like it has a reference to it.
Yeah,
like,
it's got generations and things.
I think there's a point buried down here a little bit, which in some ways is like even more important than the caching improvements, where I think the current behavior of one image potentially constantly rebasing per build is like not very noticeable when you're just pushing little Node or Go apps and stuff. But like some of these app types, like the Java native build pack, they like literally need 8 gigs per build pod. So like if you have just like 3 of those and each has 5 and they're all rebuilding, like that's actually a ton of memory. So I think supporting like Java apps or bigger apps like would really benefit from the one image per app thing we're talking about.
Yeah, feels like it's the way you're supposed to use Kpack. It's like people who use Kpack standalone, they push a Kpack image, and then they just like they keep pushing to the Git repository or whatever, and Kpack notices and makes a new build, but you never create a new image every time. You keep one for every Git repository, which is like very conceptually very close to what a CF app is basically.
Yeah,
it's like one code base changing over time.
Someone who works on Kpack at one point made a comment saying that the way we're using it, we'd be better off making KPAC builds and just like orchestrating them ourselves instead of one image per our logical build. So like that's more feedback, I think, that what we're doing right now is a little weird.
We looked into that, but like I think that I don't remember what was the reason in particular, but like it was just a lot more convenient to just mess with the image. And
We were trying to make a rebase happen when we only had a build, and it was a bit of magic. You had to go and put the right annotations on it and the right previous versions and stuff, and it'd be loads better for image just to do that for us.
Oh yeah, for sure. The reason he suggested that was because we're not even paying attention to it when it's rebased or anything. We're just like, that just happens and we ignore it right now.
Yeah. Yes, I think if you are happy with the fact that rolling back, which again, we don't have any supported API for at the moment, will mean you don't get a rebase when you roll back, basically. Like this is the main difference with traditional CF is that if you get an update of the base image and then you roll back to an older droplet, you still have the security fixes of the base image, right? The base image is still the new one. You just use the old droplet. In Corifi, droplets kind of embed the base image. So if you roll back to an old droplet, it won't be rebased, right? It won't have the new base. But maybe that's fine as long as we document that.
Oh, go ahead.
I was going to say it's a known event as well, so we can trigger those things to happen at that point in time if we want to. If you switch to an old thing, you can check. The build says it has references to the state of the things it used to build it, like all the commits of build packs and things like that. And if you can compare that to the cluster builder and see it's not equal, then you could at that point make it launch a new build for it.
Yeah, it's also an idea. I think we didn't come up with a solution that we thought would work for that case, or like you, or even just a workaround where it's like, oh, I've rolled back. Can I rebase now manually, maybe, or something? We could figure it out, but it's probably feasible.
Yeah, I mean, to be honest, the current flow to roll back would be like using the CF stage package command, and that would, you'd give it an old package and then it would rebuild that thing.
Or use an old build and set it as the current build.
Oh, sure, yeah.
Anyway, yeah, the proposal is there. I think we have a Spike branch as well, if you're curious. Might be something you might want to pick up after all the GC madness is taken care of, maybe. Let's carry on. Payload validation exploration. Dave?
Yeah, this was just a request for feedback. Matt posted in Slack yesterday, but we finished the exploration on improving the payload validation. We think we found a good option, but the original option, which is the OZO validation repo, hasn't been updated for a while, but we did find an active fork that has like 20 stars that has been updated this year. So just wanted to have folks look at that. We put some Spike code of how that would be used to do validation of a manifest payload on the issue. So please take a look. Let us know what you think.
Yeah, I like the API. It's kind of similar to the one I had come up with for my little toy validation library.
Mm-hmm.
In terms of being maintained, yeah, that might be a problem, maybe not. Like even, I don't know, like, because even the new one is not that maintained. It's like, okay, it's got a few commits on top of the old base.
Yeah, I was going to test them out by submitting a PR to add a dependable config so that it was at least kept the dependencies.
See how responsive they are.
Yeah, responsive they are. And if they respond to that, then I'm like, okay, maybe we can trust this one.
Yeah, so yeah, I don't know. There doesn't seem to be any one that we like in terms of API and is like obviously very well maintained.
Right.
So we'll have to settle, or like just literally keep our own code. But yeah, our own code could grow. It's lots of code that you have to maintain yourself. So I don't know. Maybe it's fine.
I mean, the other option is we could have our own fork of this validation library and maintain it as needed. If it's just maintenance, there probably wouldn't be that much work to do.
Yeah, that's another thing. What does maintenance mean? Like, do we
Right.
think that there could be security bugs or stuff?
Oh yeah, just keeping the dependencies up to date is definitely a big one. And I think we could automate a lot of that with Dependabot and CI. It's just a question of if the validation is working and you don't actually have to change the logic, then yeah, there aren't going to be that many commits. So
yeah, as long as someone is fixing CVEs of the library itself, because that's also possible. This is validation, so this is handling JSON coming from outside.
Right.
So it is exposed surface.
Mm-hmm.
But yeah, I think it's fine. I think it's probably our best bet. Like best compromise between cost of writing our own one from scratch and benefits of getting like a library that we like, that gives us the errors we like, etc.
Yes.
I like, in general, I like the concept of an API that doesn't rely on those, but necessarily on those annotations, and allows you to build a validator yourself via a DSL or something. And then, yeah, we can easily wrap it around an interface, test it, mock it, stuff like that.
Right. Yeah.
Annotations suck because they at some point you need to point to a method from a string, which is confusing and like hard to track. While this one is simply Go code, which I like.
Yeah, I like it. Yeah.
So it's very easy to understand what's going on, which is a plus. And I mean, we can try it out, and if they don't maintain it, as you said, maybe, I mean, it will probably be cheaper in the end to just even fork it at some point and maintain it rather than write something from scratch. And they might as well do it for us if we are lucky.
Cool, thank you.
Okie dokie, last one. UA integration prototype.
And this is something we've been working on for a while internally at SAP, and we're trying to bring back new explores, new opportunities, and new proposals for the community. Something that we've pretty much finished, and we've also written explore stories, a UA integration, which a use case for that is like seamless migration from users. Like you have a CF instance, and then you deploy Kurifi and you point it to the UA so that you share the user base and users can immediately try it out. Yeah, I guess I have to say this worked remarkably well with not that many changes. You can take a look at the story. The hardest one is that you need to be able to pass these API server arguments to your to your API server. Other than that, it doesn't make any sense. But if you do it, then you can switch CF-Kates, the CF-Kates flag to false, and then use a regular CLI, and it just works like magic. Like it's pretty cool. So
the CLI then talks to UA, logs in with UA, and then sends the UA token, and the UA token gets sent by Kubernetes to UA, because UA is set as the IDC provider for Kubernetes, and UA does the authentication.
Which makes Kubernetes trust that token issued by the UA.
Right.
There was almost no change in Kurifi itself, other than propagating the origin, because you have the UA origin. It might not be UA, it might be something different, which we're not currently respecting in Kurifi because we're not using the UA or a provider like that. But it is just a string. It's an equivalent of the IDC prefix. It's actually what you give to the API server as an IDC prefix. So if you're admin, you're actually UA:admin, or SAP ID:admin, or VMware something :admin. So yeah, we just wanted to share this thing, and would be happy if you commented on that if you spot anything there, ideas for improvements, stuff that might not work, and things like that.
Yeah, it's the whole CF-Kates flag thing is interesting, because like I think we designed it with the idea that, okay, if it's CF on K8s, it's never going to be UA. Those two things are orthogonal. But now you have both. You have a CF on K8s on UA. So I wonder if we should change the CLI so that it's
Yeah,
like
I
it
guess
tries to
this
be
is,
clever about the presence or absence of UA, because the info endpoint, right? The root endpoint tells you if you have a UA configured, right?
Yeah.
So like maybe the CLI should use that as the discriminant when authenticating. If there is a UA, use UA or something. Or maybe, I don't know.
Yeah, this is
Should give
an
you an
open
opportunity
question,
to switch. Yeah, I don't know.
because we did it. Yeah, that was another change we needed to do. We needed to pass the UA URL so that you can serve it on the root endpoint. But we made it work somehow for our prototype. But I guess it's an open question in this explore. I mean, for now, for us, it works if you just switch off the CFK's flag. But it will be nice if you had a better way, a more seamless way of.
Yeah, I think we can make the
dealing with that.
CLI handle this better. It's just we need to make sure that if we mess with that flag, we don't break all the version of the CLI, all the versions of the CLI which have worked so
Yeah.
far.
Backwards compatibility should be
Right.
a priority, I guess.
But I think
here.
it should be feasible. It should be feasible. Or like newer versions, yeah, we'll use UA if needed. But yeah, that would mean all the versions will not use UA unless you set that, you force that to false. I don't know, maybe there is some config we can allow people to change to support all their CLIs, stuff like that.
Maybe instead of sending just a boolean, we can next to the boolean send CF on K8s flags or options or whatever, where you can specify what we support. Like first one would be UA.
Yeah, you can do stuff like that if you are willing to install the latest CLI, right?
Yeah.
If we're happy with the CLI changing, then yeah, we can probably make the CLI cleverer in terms of like these things, and because now it just looks at that flag, but it doesn't have to be that way forever.
But it was a pleasant surprise how easy it was to make this work and how little change is required and how this doesn't conflict with the way we're doing things now in the open. And yeah, actually, we should be able to work. If you configure your cluster with the UA, you should be able to use an older CFCLI as well that doesn't know about CF on K8s, which is also neat.
Yeah, you either need, yeah, exactly. You either need to use a CLI that is so old that it doesn't know anything about CF on K8s. It knows that flag,
or switch it off,
or one that is new enough to know how to
Yeah.
handle that flag and UA together.
or
and you have a
just
limbo in
switch
between where like
it,
things don't work.
or just switch it off, but that's weird because setting your CF on K8s to false on a Kurifi deployment is weird.
It is weird. It's funny that it works, but
Yep.
it feels very wrong. But again, it may be the only way to make those CLIs in that period kind of actually work in this scenario. So if it works, maybe it's as a temporary workaround, it's acceptable. I don't know.
So is there anything special about UAA in this context, or could this be any OAuth 2 provider?
From
I
the
think
CLI
there
standpoint, I
was-
think it needs to be UA because the CLI only knows how to talk to UA.
Oh, okay.
Yeah, we're not really using OIDC. Yeah, we're not really like the only thing we're using OIDC for up at this point is to configure API server just so that it trusts the UA. But other than that, we don't do the whole IDC dance, the flows, anything. We're just talking directly to the UA with some user password flow, basic. But actually, we also experimented a little bit with the kubectl OIDC plugin so that you can be the kubectl user against Kurifi that's configured with the UA. You can still do the thing. You can use the OIDC plugin. It will do the redirects, and you'll be able to log in. Which is interesting. We don't really need that for now, but it's interesting. And at this point, it could be anything.
Yeah, I think we did something very similar on the VMware side, using like Pinniped.
Yeah, because basically UA supports OIDC, Kubernetes accepts any OIDC, and you're lucky enough that when you use UA with all the APIs, with ones used by the CLI, you get the same tokens that you will get if you went through the actual OIDC login. Which means like once you have that token, any UA token works. And the CLI knows how to get those tokens natively, and it's all like with the username and password flow. Which means like it gets the token via the old flow, and then it sends it to Kubernetes, which verifies it using this OIDC integration with UA, and it works. At the beginning, we were like, is it going to work? There are two different types of token that are obtained via very different flows, but apparently they're interchangeable. So that's neat. I think that's the trick, I guess, that makes it work.
And did you spin it so that you can actually pass those arcs to any cluster that you provision on Amazon or wherever? Because you need to pass the IDC flags, right? Yeah, we might. Yeah, I think we have control over our arguments in the ACP environment. So we want to deploy this, but we might want to experiment with this as well at some point potentially. For now, we're working on kind. So it's pretty cool actually. I'm able to log in on the kind deployment using my company credentials because we're just pointing to a UA, which is the official ID. It's impressive.
Wow, such power.
Yeah.
Nice. I think we might be done if we don't have anything else. All right. I will see you all in 2 weeks then.
Bye, everyone.
Thank you.
Bye.
Bye-bye.